Good morning, friends. Let's continue our discussion about shared variables. So in the previous video, we have already learned about the broadcast variables. Now in this video, we will keep on continuing our discussion about accumulators. So the accumulators are the variables which are used to aggregate the information through associative and commutative operations. Associative operations are something like math in mathematics, like in for summing and for addition and for multiplication. We call these two operations as associative. What associative means is that, for example, say in our addition, we have got three numbers, 2 plus 2 plus 5. So whatever way we group it, like if we group 2 plus 5 together, the answer is still same as 9. And if we group the first two elements, the first two numbers, 2 plus 2, and do it first, after then we add 5, in that case also the answer is 9. But multiplication and divisions are not associative as addition and multiplication. So just for an example here, if we change the order here, for example, if we do 2 minus 1 first and then subtract after this, so the answer would be 3. But if we subtract 4 and 2 first, so 2 minus 1 would be 1. So the answer is not same. So it means that subtraction is not associative. Similarly, if we talk about the commutative operations, the commutative operations are like that if we change the order of the operands. For example, if we have got 2 and 3, if we add it, it will be giving 5. And if we change the order, so if it has like 3 first and then 2 afterwards, again the answer would be again 5. So addition is again commutative as well. So addition and multiplication are commutative. But in contrast, if you talk about subtraction and division, so they are not associative first of all, and also they are not commutative. Because if we change the order, the results would be different. For 2 minus 7, it would be giving minus 5. And if I change the order, 7 minus 2, it would be 5. So the answers are not same. So that's why we have to remember that addition and multiplications are associative and commutative, but subtraction and division are not. So why these concepts are very important when we are talking about accumulators? So let's learn about that. So as discussed that accumulators are variables that are only added to through an associative and commutative operations and can therefore be efficiently supported in parallel. This parallel operations, when you are using in Java, when we are using parallel streams, so only those operations which are associative and commutative, only those operations can be run in parallel using parallel streams. The same concept goes in Apache Spark when we are talking about accumulators. Because the reason is that, as we know that in our main diagram, that the driver program, it will having the Spark context and it will delegate all those executions, all those transformations and actions, operations that we are doing on the RDD on the worker nodes. So if whatever operation that we are transforming, that we are executing on several worker nodes in executor, on all those executors for all those tasks. So this can be spread randomly, right? If, for example, if it's not grouped same as before, if you are running it multiple times, it can be grouped into different format. And if it is not commutative or associative, then the parallel operation that we are performing on the RDD data, that would not be consistent. Because if they are not associative or commutative, whatever way, we cannot control that how it is being grouped or it is being ordered when the data is spread across all these worker nodes. So that's why whenever we are using accumulators or whenever you are using parallel streams operation in plain Java, in that case, we have to ensure that if we are using associative and commutative operations, only then it will be correct and giving us the consistent results. So accumulators in Spark, they can be used to implement counters as we do in our MapReduce. That, for example, we can get the, let's say, sum of first 10 numbers like that. And also we can use this as a product. So for example, if you want to get the factorial of, say, a product of a number, in that case also we can use the accumulators. Now, Spark natively supports accumulators of numeric types. For example, it's like long or double or whatever. So this is natively supported. And if we want to have a custom object of ourselves that we want to act as an accumulator, for that also there is one API which we'll learn very soon. That is accumulator version 2, V2, which can be used as an accumulator. So there are various ways that how we can calculate, how we can create an accumulator in Spark. For example, we can use the Spark context, and then we can call this long accumulator method to get a long accumulator. Similarly, we have got for double accumulator. And the tasks running on a cluster can then add to it using the add methods. So all these APIs, we will go through all in actual code examples in details. So these are the various APIs that we can use to perform our accumulation. One of them is add method. So when we are running it on a cluster, I mean, when it's running on the, say, worker nodes in the executors, so we can perform all these operations, but we can only get the accumulator value only in the driver program. So again, if we talk about this diagram here, so we can perform all those operations like add and everything here in executors. But once we want to get the actual value of the accumulator, that can be only done on the driver program, not on the executor. Okay, so again, let's go back here. So this is the API by which we can get the actual value only in the driver program. Now, also we have learned previously that Spark supports two types of operations: transformations and actions. So transformations are something which will be lazily done, and it will also always create a new RDD from the previous RDD. So this is what transformation does. And if we are going to do any update on the original accumulator value, and if you are using only the transformations, for example, if transformation actions are like map and reduce, map and filter, for example. So these are all transformations. It will always create a new RDD, and it is done lazily. This lazy evaluation is very important here because it can be applied more than once. If you're updating the accumulator value more than once, and we are only using transformations till now, so this would be always executed and applied more than once. But once we are doing actions, so actions are not are different than transformations. And whenever any action is called, for example, count, but collect, take, and all. So that's when all the operations, previous operations, would be performed by the Spark, and the value would be generated. And if we are updating the accumulator inside an action, that would be applied only once. If we again perform that same task again, then it will not be updated. So again, we will learn about this when we actually go through the code examples. And as mentioned that if we are creating our own new types, not actually using a long or a double or a native type, for that we can create all our own accumulators by subclassing this accumulator v2 class. And this has got, again, a lot of, actually this is marked as an abstract class in the API, in the Spark API. And it has got several methods like reset for resetting the accumulator to 0, add for adding another value, and merge for merging another same type into this one. And if you go to this API documentation, I'll put in the link. So here is this accumulator v2 link for Spark 3.5.0 version. This is the latest version. And here, if you want to learn more about all these various methods, you can always refer it here. So guys, this was all about accumulator theory part. In the next video, we will deep dive into all these concepts that we have learned, that how to create a long accumulator, how to create a double accumulator, and how to create your own types. So we'll learn all this in the actual code. So see you guys all in the next video.